Hi everybody, I am Dr. Vivekananda, Assistant Professor, Department of Mathematics and Management Sciences. Today I am going to give a lecture on the course of Fourier and Complex Analysis of Unit 3, Integration Function and Power Series. Topic is we are going to discuss the problems on integration of complex functions using Cauchy's integral theorem and Cauchy's integral formula. So evaluate integration over C, z square plus 4 by z minus 3 dz, where C is a, we have two problems, means two curves here provided here, that is mod z equals to 5 and another curve is mod z equals to 2. Okay, so first thing is you have to evaluate integral means singular points. You have to evaluate singular points. First, what is a given integrand? Z square plus 4 by z minus 3. This is the given integrand. For this, we evaluate singular point. Singular point is z minus 3 is equal to 0. That implies z equals to 3. I evaluated singular point. Next, you take the curve A. Question A. So what is a curve? Curve means mod z equals to 5. Mod z equals to 5 is nothing but is a circle. With the center at origin of radius 5 units. Means so this is the curve, this is the circle drawn with 5 units radius. Okay, so it's a circle with, this is a circle of radius 5 units. Okay, now what is a singular point? Here singular point 3 na. Singular point 3 is lie inside the circle. Here the singular point z equals to 5, sorry, z equals to 3, which is less than 5, lie inside the circle. If the singular points lie inside the region, then we need to approach Cauchy's integral formula. What by Cauchy's integral formula? What is saying? By Cauchy's integral formula. What it says? Integration over C, f of z by z minus a into dz equals to 2 pi I into f of a. This is Cauchy's integral formula. We are applying Cauchy's integral formula for this integration over C. What is f of z here? F of z is z square plus 4 by z minus 3. F of z is z square plus 4. And z minus a means z minus 3 dz equals to 2 pi I into f of a means f of 3. Here f of z equals to z square plus 4. Here f of z equals to z square plus 4. Then f of 3 means 3 square plus 4, which is equals to 13. So 2 pi I into f of 13 means f of 3 means 13, which is equals to 13 2 ja 26 pi I. So this is the integration of z square by z square plus 4 by z minus 3 dz. This is for A. This is for A, for the question A. Similarly for question B is what? Mod z equals to 2. Question B, we have to evaluate integration for mod z equals to 2. Mod z equals to 2 means is a circle with center at origin of radius 2 units. Means so this is a circle. This is a circle this is a circle of radius 2 units, and here z equals to 0, and here z equals to 0. Okay, so then here the singular point, here the singular point. So what is the singular point here? Z equals to 3 na, which is greater than radius 2, is lie greater than 2, is lie outside the curve circle, mod z equals to 2. Therefore, then the function, what is that function? Z square plus 4 by z minus 3. Therefore, z square plus 4 by z minus 3 is analytic everywhere. Is analytic everywhere in C. In and on C. Everywhere analytic in and on C. In and on C. So therefore by Cauchy's integral theorem, Cauchy's integral theorem, therefore by Cauchy's integral theorem, integration over C z square plus 4 by z minus 3 dz is going to be 0. The integration value is going to be 0. This is what? Evaluation of integration. Evaluation of that integration is going to be 26 pi I with respect to A, and with respect to the question B, the integration value is going to be 0. Okay, so this is another type of question. These type of questions also important for the exam point of view. Next question. Evaluate sin pi z square plus cos pi z square by z minus 1 into z minus 2 dz, where c is mod z equals to 3 using Cauchy's integral formula. Now first step is you need to find the singular points. First you need to find the singular points, then sketch the region, then you check the singular points will lie inside or outside, then accordingly you proceed. So now here integrand is sin pi, that is not n, sin pi z square plus cos pi z square by z minus 1 into z minus 2. Okay, this is a given function, means integrand function. Here singular points. Singular points means you just equate the denominator to 0. Z minus 1 into z minus 2 is equal to 0. That implies z equals to 1 comma 2. Z equals to 1 comma 2. You will get these are the singular points. Next, we evaluated singular points. Now you try to see the region. You try to sketch the region. So what is that? Here C is mod z equals to 3. Mod z equals to 3. So mod z equals to 3 is a circle. A circle with center at origin, of radius 3 units. Okay, means you sketch the graph here. So this is a circle of radius 3 units, at center 0. We evaluated singular points. These singular points lie inside or not, you check. Singular points, what are those singular points? Singular points z equals to 1 comma 2, which are less than to 3, radius 3. Therefore, the singular points, if they are less than radius, means they lie inside. The singular points lie inside circle. Inside circle, mod z equals to 3. Both are lie inside, not only one. Both lie inside. In this case, we need to split the given integration according to the singular points. We need to split. After finding the singular points, both singular points are lie inside, you have to Apply partial fractions and split the given integrand into two parts. Then go for applying Cauchy's integral formula. So now what I am doing here is sin pi z square plus cos pi z square by z minus 1 into z minus 2. Okay. Cos sin pi z square plus cos pi z square by z minus 1 into z minus 2. This I am applying partial fractions. I am writing this as sin pi z square plus cos pi z square by z minus 2 minus sin pi z square plus cos pi z square by z minus 1. I split it into two fractions. I split it into two fractions by applying partial fraction concept by partial fraction. This I evaluated by partial fraction. By applying partial fraction concept, we splitted that. Since they both lie inside the circle, so I split it into two fractions. Right. Now, which is equals to integration sin pi z square plus cos pi z square by z minus 2 into dz minus integration sin pi z square plus cos pi z square by z minus 1 into dz. As z minus 1 and z minus 2 are the singular points, z equals to 1 and 2 are the singular points lie inside. So by Cauchy's integral formula, Cauchy's integral formula, we write that as integration 2 pi I into f of 2 plus 2 pi minus here minus, no, not plus, minus is there, na, minus here minus is there, na, so I am just putting minus here. 2 pi I into f of 1. You write down Cauchy's integral formula, integration over C f of z by z minus a into dz equals to 2 pi I into f of a. According to that formula, I am writing 2 pi I into f of 2 minus 2 pi I into f of 1. Here f of z equals to sin pi z square plus cos pi z square. So then what do you get? 2 pi I into f of 2 means sin 4 pi, na, z square 2 square is 4 pi, sin 4 pi cos 4 pi. So that I am writing here sin 4 pi plus cos 4 pi minus 2 pi I into 2 pi I into f of 1. F of 1 is, if we put z square by 1, z by 1, sin pi 1 square means sin pi plus cos pi. So sin pi plus cos pi. So which is equals to 2 pi I into sin 4 pi is 0, cos 4 pi value is 1, as 2 pi I am taking common, minus sin pi is 0, cos pi is minus 1. So minus into minus plus, 1 plus 1 is 2, 2 into 4 pi I is 2 into 2 pi I is going to be 4 pi I, 4 pi I, like this. Okay. So once again I am just recalling. First take the integrand. For that integrand function, singular points you evaluate, and after that sketch the curve, and singular points lie inside or not you check. Here we have two singular points, both the two singular points lie inside. So you try to apply partial fraction and split into two fractions. To every fraction you evaluate integration according to the Cauchy's integral formula. Okay, so this is the way of, this is another model questions. Even this model questions also mostly asking for the end examinations. You try to follow the concept and try to apply. Okay, next question. These type of models are very important. So they are asking very frequently these models. So evaluate integration over C 1 by z square plus 9 dz. So what is the integrand function? You first identify. What is the integrand function? So 1 by z square plus 9. For that evaluate singular points. Singular points means you just equate the denominator to 0. Singular points equate to 0. From this you will get z equals to plus or minus 3i. Z equals to plus or minus 3i are the singular points. We evaluated singular points. Now you take curves. First one C is modulus of z minus 3i is equals to 4. Is also a circle. Is also a circle. Okay. Is a circle. Is a circle with center at 0, 3 of radius 4 units. Of radius 4 units. Okay. Now, whether the singular points lie inside or not, you check. First, your singular points you identify, you write them separately. Singular points z equals to minus 3i comma plus 3i. Now at z equals to singular point at z equals to z equals to 3i minus 3i you take. Z equals to 3i you take. Minus 3i you take. Z equals to minus 3i. Whether this singular point lie inside or not, you check. How you will check now here? Modulus of z. Put z by minus 3. 3i minus 3i. Okay. In the place of z, substitute minus 3i. This is the technique you apply for finding the singular point lie inside or not. Is equals to 4. That implies determinant of minus 6i. Minus 6i value is going to be minus 6i value is going to be what is going to be 6 only, is going to be 6, which is greater than 4. What is the radius? 4 na, which is greater than 4. So therefore z equals to minus 3i lie outside the region, because with respect to z equals to minus 3i, the function means that value is going to be more than 4. So therefore this point lie outside the circle, outside C. Okay. Similarly, z equals to 3i you take. We evaluated one singular point lie outside. What about z equals to 3i? Is lie inside or outside? You check. Put z equals to 3i minus 3i. Value is 0, which is less than 4. That implies z equals to 3i lie inside the circle, inside C. Inside C. Z equals to minus 3i lie outside the C. That is modulus of z minus 3i is equal to 4. Z equals to 3i lie inside the circle. Means one singular point is lie inside, one singular point is lie outside. If both singular points are lie outside, lie inside, we evaluated in previously. If both singular points lie outside also, we evaluated. If one singular point lie inside, one singular point lie outside, what to do? So what to do na? See, the given integrand, the given function what? 1 by z square plus 9 na? 1 by z square plus 9. This is the given integrand, the given function. So this can be splitted into z plus 3i into z minus 3i. I split it into factors. Okay. So in this, z equals to 3i inside means z minus 3 I has to keep in the denominator, means I am writing z plus. So here z equals to minus 3i is lie outside na, so that I am bringing to numerator by z minus 3i, because 3i is lie inside, means z minus 3i is the factor, minus 3i is lie outside, z plus 3i is the factor. So which singular point lie outside, that will be taken into numerator part. Which singular point is lie inside, that factor keep in denominator. Now for this we have to evaluate integration. Integration over C, 1 by z square plus 9 dz can be written as integration over C, 1 by z plus 3i by z minus 3i into dz. So by Cauchy's integral formula, we write this as 2 pi I into f of 3i. F of 3i, because 3i is a singular point which is lie inside. So here f of z is, here f of z equals to what? 1 by z plus 3i. This numerator is f of z. Okay. So which is equals to 2 pi I into f of means 1 by f of 3 f of f of 3i means 3i plus 3i, which is equals to 2 pi I into 1 by 6i. I get cancelled, 2 1 ja, 2 3 ja. So which is equals to pi by 3. So this is the integration. Integration over C 1 by z square plus 9 dz, where C is what? Mod z minus 3i, mod z 3 minus 3i is equals to 4, is equals to 4. This is what evaluation of integration with respect to the circle mod z. Okay, this I wrote as per the Cauchy's integral formula. Cauchy's integral formula. Okay. Next, what is second question? Modulus of z plus 3i is equal to 2. Second question, 1 by, sorry, C is what? C is what here? Modulus of z plus 3i is equal to 2. Modulus of z plus 3i is equal to 2 is a circle with center at 0 comma minus 3 of radius 2 units. Now in this circle, those singular points, what happened those singular points, where it lies, inside or outside, we'll check. Now the singular point, the singular point z equals to minus 3 you take. So at z equals to minus 3i plus 3i. In the place of z I am putting minus 3i. So the value is going to be 0, which is less than 2. That implies z equals to minus 3i lie inside circle. Lie inside C. Next, what about z equals to plus 3i? Modulus of 3i plus 3i. Its modulus value is going to be 6, is greater than 2. That implies z equals to plus 3i lie outside C. Okay, one is lie inside, one is lie outside. Which one is lie outside? That will be taken to the numerator part. So the integrand 1 by z square plus 9 dz can be written as, which one is lie outside? Z is equal to 3i na. So z equal to 3i means z minus 3. Z minus 3i by lie inside means z plus 3i, that keep in the denominator. The part which lie inside will be taken into denominator part. Okay, because z equals to minus 3i lie inside, so I kept in the denominator part, where z equals to 3i. Z equal to 3i means z minus 3. So that singular point is lie outside. So I am just taking that part, that factor part, to the numerator. So by Cauchy's integral theorem, we write this as 2 pi I into f of minus 3i, because the singular point z equals to minus 3i lie outside inside, na? So we evaluate the function. Here f of z equals to, here f of z, here f of z equals to 1 by z minus 3i. So which is equals to 2 pi I into z minus, means in the place of z you write by f of minus 3i. F of minus 3i means 1 by minus 3i minus 3i is going to be minus 1 by 6i, minus 1 by 6i. So I get cancel, 2 ones, 2 threes. So it's going to be minus pi by 3. This is the integration of 1 by z square plus 9 into dz, into z dz, where c is modulus of z plus 3i is equal to 2. This is the integration value with respect to second question. So the last one, third one is, what is third one? Mod z equals to 4. Mod z equals to 4, third one. Mod z equals to 4. Mod z equals to 4 means is a circle. A circle with center at origin of radius 4 units. Okay. Now z equals to minus 3i you take. So then modulus of minus 3i is going to be 3, which is less than 4. That implies z equals to minus 3i lies inside C. Next, z equals to plus 3i. Modulus of 3i, the value is going to be 3, which is also less than 4. Z equals to plus 3i also lie inside C. Both are lie inside. Both are lie inside. So in this case, I want to split this. The given integrand we have to split into 1 by z plus 3i into z minus 3i, na? Split into factors. Then by splitting into partial fractions, 1 by z minus 3i minus 1 by z plus 3i. When you simplify this, you will get numerator by 6i. So that 6i will be get balanced by dividing 6i. Integration over 6 dz. Okay. By splitting into partial fractions, I am getting as 1 by 6i into 1 by z minus I minus 1 by z plus 3i. This has happened by partial fractions. By partial fractions. Okay. Now we have to evaluate this. So which is equals to, see, by splitting into partial fractions, 1 by 6i into 1 by integration of over c, 1 by 6i into integration of over c, 1 by z minus 3i minus 1 by z plus 3i into dz. So now Now 1 by 6i integration over c 1 by z minus 3i into dz minus integration over c 1 by z plus 3i into dz. So as per the Cauchy's integral formula, we write this as 2 pi I into f of 3i minus 2 pi I into f of minus 3i. You try to simplify this. You will get the value. That's all. Okay. So this is the way of finding complex integration using Cauchy's integral theorems, Cauchy's integral formulas, and Cauchy's generalized integration formulas. Okay, students. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.